Good day. Um, my name is Quentin, and I'm here to present um, the project which I have done for WRM, and on the screen is my details. Project disclaimer: this project is for academic purposes, and it is just to evaluate the understanding of the student regarding the module, and no actual um, field work was done, or no institution was contacted. Um, so neither the student nor unison or lecturer may be held liable for any unreasonable expectations. Um, Number two, um, introduction. The project was intended to to provide a water supply distribution network to supply 6 townships um, with with water. And then on the next slide, it actually shows um, the general layout where the water is taken from the river and then to the water treatment plant, and then from the water treatment plant to the reservoir, and then from the reservoir to to the pipe here, to this connection junction here, junction number 1, and then from junction number 1 to junction number 2, then distribute to the different demand centers, which will be which are townships. And then from junction number 1 as well goes to the right side to junction number 3, from junction number 3 to different demand centers, which are townships, which represents townships. Next slide. Water distribution system. The purpose of a distribution system is to provide water to consumer while maintaining the appropriate standard in terms of quality, quality and pressure for water. The distribution system is used to describe the collectively the facilities used to supply water from its source to the point of usage. In this network system, we used EPANET. EPANET is the software, it's a global software. It is free to use, but it's mainly used to model water distribution systems under water basic movement and analyze distribution systems. So it helps with designing new infrastructure and supplying optimization and reducing energy usage and investigation of water quality issues. Next slide. In the literature review, this report uses EPANET software to analyze a South African bulk water supply network. So applying basic hydraulic principles to determine its components such as pipe diameters, flow rate, flow velocity, pumping head, head available from the reservoir. And then the parameters that were used for the elevations. from the river, from junction number 1 up until 2, and different demand centers and junctions, and the water treatment and the bulk reservoir are shown on the table, and the differences and the difference between the benchmark, which is the zero level, which is the river level, which is 900. The So it's 943 minus 900 is equal to 43. So that is the difference in elevations. And then next slide, pipe diameters, average daily pipe diameters and average daily demands. These are the diameters that we used. It was initially we used 300 diameters, all of the pipes, and these are the different average daily demands. On the next slide, and after running through and putting all the uh, all the all the given information in the EPANET, we realized that we were experiencing negative pressures. And then to adjust and to alleviate the problem of negative pressures, we adjusted 3 pipes. The first one, the pipe number 1, and from 300 diameter adjusted to 350, and pipe number 5 adjusted from 300 to 350, and then pipe number 9 from 300 to 450. And then afterwards, the results came positive afterwards. So here's the conclusion. After adjusting and increasing pipe 1, 5, and 9 diameters, the pressures are positive and analysis ran successfully. And then after adjusting and increasing pipe 1 and 5 and 9 diameters, velocities as well were found to be less than 1.5 meters per second, and the analysis ran successfully. So 2 pumps are required in this network, and the first pump is essentially to generate the necessary pressure for conveying water from the river to the water treatment plant, while the second pump helps transferring the treated water from the plant to the reservoir. Therefore, the water stored in the reservoir can be distributed to different demand centers. And the network was ran very successful, and therefore the network will successfully be able to supply water to different demand centers from 1 up until 6. And in conclusion, that is a screenshot of a network that ran successfully. And end of the presentation. Thank you very much. Thank you.